Hi everyone, welcome to this lecture. So in this lecture, we will learn about the bias variance trade-off. So while learning about the concept of a bias and variance of the regression model, we will also understand the concept of overfitting and underfitting model. So what is bias and what is variance? What are the definitions of these two quantities? So bias is the difference between the prediction of model and the true value. So basically bias is the error. If we see the first line, it is telling us that it is the difference between the predicted value and the true value. High bias models pays very less attention to the training data and oversimplifies the model. So what happens is if a model has high bias, it does not pay attention to the training data. That is, it does not try to learn all the pattern present in the training data and hence oversimplifies the model. So we can understand the concept of oversimplification with the help of a polynomial regression. So what happens if a model has high bias, that if we need a polynomial of degree 4 in order to fit on the training data, but if the model has high bias, it will not pay attention to the data and it will try to fit a polynomial of degree 1 and 2. In that way, it will try to oversimplify the model by not paying attention to all the essential patterns present in the training data. So in this way, it will always lead to high error on training and test data. So a high bias model has high error both on training component and the testing component of the data. On the other hand, a variance of a model is the variability of a model prediction for a given data point or a value which tells us spread of our data. So what happens when a model is trying to predict some data sample or test sample? In that way, sometimes the prediction is close to the true value and sometimes it is far away from the true value. In that case, we need to calculate the variability of the model prediction, and that is defined by the variance of the model. So model with high variance pays a lot of attention to training data but does not generalize well on unseen data. So if the model has high variance, it tries to learn some extra thing rather than the normal pattern of the data. Extra thing means it tries to learn the noise of the data as well. So what happens in this way? In this way, it will not generalize well on unseen data. That is, its test performance becomes poor. On the other hand, it performs very well on the training data. So what is then bias variance trade-off? So in order to build a better model, we end up building a complex model which leads to bias variance trade-off. So model with high bias is called underfit model. So here comes the definition of underfit model. If a model has high bias, it is called underfit model. And if a model has high variance, it is called overfit model. So underfit model does not learn the training data well, while the overfit model tries to learn the noise of the data as well. So both underfit and overfit models do not generalize well on unseen data. So the common thing between underfit and overfit model is that their testing performance is very poor. So we need models which are good fit, neither underfit nor overfit. So what is basically bias variance trade-off? In bias variance trade-off, what happens is that we want to build a better model. In that way, our bias and variance becomes high. So we have to compromise on one of the parameter. Either we have to compromise on the bias of the model or the variance of the model. If we need a model with low bias, so in that case, we compromise on the variance or the value of the variance. We may accept a model with a bit high variance in that case if we need a model of a low bias. On the other hand, if we need a model of a low variance, in that case, we may compromise on the bias value of the model. So that is called a bias variance trade-off. That is, in order to accept one value, we have to compromise on the other value or on the other parameter. So that compromise is called bias variance trade-off. So high bias has a underfit condition, that is a model with high bias is called underfit model. So we do not need a model which is both underfit and overfit. If a model is only underfit, we can try to improve it, or if the model is only overfit, we can also try to improve it by adjusting either one of the bias value or the variance value. But if the model is both underfit and overfit at the same time, we cannot accept that model. So we need model which are good fit according to our data set. So here is the overfitting. So overfit model tries too hard to fit the training data and thus learn the noise of the data as well. An overfit model performs well on training data but performs badly on a test data. An overfit model has low bias and high variance. So basically, if the model is overfit, it tries too hard to learn some extra thing. Suppose we want to train the model to classify trees. So in order to classify trees, if we give the information to the model that the stem of the tree is brown and the leaves are green, it will be enough information for a model. But if we also provide the model the information that a tree has 32,000 leaves, in that case, this is an extra learning, or this is the noise of the system, because every tree doesn't has 32,000 leaves. So what happened in that case, it will perform well on the training data, because your training data has the trees which has leaves equal to 32,000. But maybe on the test data, we have to test our model on the trees which doesn't have 32,000 leaves. In that case, it performs badly because it has learned some extra feature or the noise of the data. So in overfitting, model try to too hard to learn everything of the data, due to which its performance is poor on the testing component of the data. So what are the reasons of overfit? So there are large number of features in a data and many of them are irrelevant. Suppose we have 100 or more features in a data set. So if we have so many features, then there will be some repeating features or multi-collinear features, or the features with more dominance. In that case, model will try to focus more on the features which has high value or which are more dominant features. The other reason is the value of features are not standardized. So we need to standardize the data in order to avoid overfitting. Our model learns the noise of the data. It means other than the regular feature, model also learns irrelevant things that are present in the training data. So during overfitting, the model is not generalized well on unseen or test data, and hence we get large error. So its performance will be okay on the training component of the data, but on the testing part, we get a large error for a overfit model. So this is the example of overfitting. We can see that these are our data points which are shown in light blue color. So here in magenta, we can see that our model is trying too hard in order to accommodate every point which is not necessary. So what happened in that case, we can see that it is accommodating all the training point, and in that way, its performance on the training part of the data set will be very good. But when it comes to testing, so if the testing point is even slightly away from the regular training part, it will not be able to classify it, or it will not be able to perform well or to predict the value for this test point. So in that case, overfitting model is trying too hard in order to get the information from the training data so that its training performance will be good. But during the testing time, it will not be able to predict well about the test data points. Now comes the definition of underfitting. So an underfit model does not fit the training data well, and therefore unable to capture the fundamental or elemental pattern in the data. An underfit model does not perform well on training and testing. An underfit model has high bias and a low variance. So if a model is underfit, it has a high bias and a low variance. Why it is underfit? Because it does not try to fit well on the data. It does not learn the fundamental or elemental pattern present in the data. So it tries to oversimplify the model. So its performance on both the training and testing component is poor. So this is the example of underfit data while training and testing, and we can see that even on the training, the error is very large. Look at this point. This is far away from our underfit model, and this is also far away from our underfit model. In that situation, we will get a high error during training if our model is underfit. So during the testing, the error will remain same. That is, we will get the high error during the testing as well. So here is our test data point, and we can see that model is not paying any attention to this point. In that case, our testing accuracy or testing prediction will also be poor. So underfit model performs poorly both during the training time and the testing time. Now this is a good fit model. If a model is not underfit nor overfit, then it is a good fit model. So here we can see that model is trying to learn all the pattern present in the data. In that case, it is leaving few of the data point, which is okay. But it is learning the important pattern. Look at this model. It has learned the variation of the data points. So it will perform well both during the training and during the testing. So this is the bull-eye view of a bias and variance. So we may have 4 kinds of model. This is called a low bias and a low variance. So here we have the bias values on the vertical axis and the variance values on the horizontal axis. So this is an ideal situation where the model has low bias and low variance, but it is very difficult to achieve this kind of model. We have to compromise on any one of the value. Now here is another model. This model has a low bias but a high variance. So due to low bias and high variance abilities, this model is known as overfit model. Now the third model has a high bias and a low variance. Due to high bias and low variance, this is the underfit model. This fourth model is a high bias and a high variance. We cannot accept this model because we cannot improve both the bias and variance at the same time. So what happened in bias variance trade-off? If we need a model with low bias, then in that case, we compromise on the value of the variance. That is called a bias variance trade-off. On the other hand, if I need a model with a low variance, so I can compromise on the value of bias. So this is called the bias variance trade-off. So in this lecture, we learn about the bias and variance trade-off. We learn the important concept and definition of bias and variance of the model. We also learn about the concept of overfitting and underfitting. We learn the reasons of overfitting, and we also learn the reason of underfitting. We learn that the overfit model has high variance while the underfit model has high bias. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.